Symmetry concept and dipole moment is another topic that we are going to discuss now. In the earlier video, we have described about the symmetry concept and the optical activity. So the physical properties and certain chemical properties are also very sensitive to the symmetry idea or the symmetry concept. Let's visit the same concept now for the dipole moment. I'm your instructor, Saurabh Maktibodh. Well, dipole moment and symmetry, when we talk about the dipole moment, we talk about the vector quantity that is certain direction, and it is there because of the orientation of the molecule in the space. For instance, if we have in a molecule the two vectors which are acting on opposite directions, then they are going to cancel out the effect of each. Similarly, if we have a triangular linear molecule, the two vectors, the resultant of these two vectors would be cancelled by this vector. So net dipole moment of this molecule would be 0. Similarly, if you take about a square planar molecule, then the vectors are cancelled mutually and the net result is 0 dipole moment. What does it imply? It simply implies that molecular dipole is dependent on symmetry. So that's why the symmetry concept may be or regarded as useful concept. Any molecule with an inversion center cannot have a dipole moment. That's a very classical idea about it. If a molecule has a center of symmetry, then it cannot be a dipole. It cannot have a dipole moment. So net dipole moment would be 0. Any molecule with Cn perpendicular to Nc2s cannot have a dipole moment. Generally, when you talk about the flat molecules or flat structures, these molecules are very symmetrical and they have 0 dipole moment. Any molecule with an Sn cannot have a dipole moment. Sn point group, or if they have an Sn axis, that is an axis, principal axis perpendicular to the molecular plane, because the two things are going to exist, and as a rule they will not have a dipole moment. It has been found that only C1, Cs, Cn and Cnv point groups can have a molecular dipole or net dipole moment, and therefore they are considered to be polar. Symmetry, however, does not tell us the direction or the magnitude of the dipole moment. But sometimes, if you talk about the direction, C1 could be of any direction, Cs belong to any direction except perpendicular to Sn, that is perpendicular to the principal axis. Cn and Cnv must be Z or minus Z. It implies that when you're talking about such molecules, the principal axis is actually assumed to be Z axis, or therefore either on direction side of Z or opposite to Z, it have a dipole moment. If you try to visualize for this, if you talk about this molecule in Z axis, the two vectors are going to cancel out, and if you have these three bonds in an XYZ plane, so if you're considering the Z axis is perpendicular to the XY plane and the molecule is having a net dipole moment of 0. So this is very important in assigning the directions. Cs could be of any direction, that is what we are saying. Cs could belong to any axis except perpendicular to Sn. Cn and Cnb must be perpendicular to Z or minus Z, that we have seen right now. As far as the magnitude is concerned, magnitude depends on the atoms, lone pairs and bond dipoles. If there is a difference in electronegativity, then the molecular bond would be the polar bonds, and the lone pairs of course contribute significantly. Let us take an example of ammonia molecule. Ammonia molecule has got a lone pair, and the NH bonds have polarization towards nitrogen because nitrogen is more electronegative than hydrogen atoms. So net result is there along the Z-axis, and you can see that the bond pairs and lone pairs are in the same direction. So this molecule is obviously a polar molecule with a strong dipole moment. However, when you talk about NH3, now the case is reversed. The bond pole, because now fluorine is more electronegativity than nitrogen, then its direction would be reversed. However, the lone pair would continue to contribute in the upward direction, and as a net result, the molecule as a whole is nearly a 0 dipole moment, though this is a pyramidal molecule. Nearly 0, it's not absolutely 0. So that's why the direction can be seen only in terms of the bond dipoles and the lone pairs of the structures. Why symmetry and dipole moment matters? Of course, because the dipole moment is considered with the solubility, miscibility, boiling and melting points of various substances, their pK values, and of course vibrational transitions, including the crystal structure and their properties. So these are certain physical properties that can be described well in terms of the dipole moment, and that's why the study of symmetry is important and the geometry of the molecule is important. In the earlier videos, we have seen that the point groups can be assigned only by just observing the shapes. That video was regarding the summary of shapes. And with this summary, we have seen that the molecules with the low symmetry C1, CS, CI, they're non-axial point groups, and the cyclic, that is CN, CNV, and CNH, and the acid, they are cyclic kind of compounds. Whereas the dihedral molecules are generally classified as DN, DN, DNH, the flat molecules which have n number of perpendicular C2 axes. The polyhedral molecules like tetrahedral, octahedral, icosahedral molecules are not shown in this figure. Of course, linear molecules have their separate existence if they are C infinity V or D infinity H, depending upon whether they do have I or they don't have I. So, conclusively, we can say that the symmetry allowed molecules are those which have a point group of C1, CS, CN, CNV, and the molecules with symmetry forbidden, that is, there is no symmetry, it is center of symmetry because Ci has a center of symmetry, it is not having a dipole moment. Sn, DN point groups because Cn is perpendicular to NC2s. DNH because they're containing a Cn with NC2 and mutually perpendicular with a flat sigma H horizontal plane. DND, tetrahedral symmetrical, octahedral and icosahedral kind of structures, they should not have a dipole moment. So allowed dipole moments are C1, CS, Cn, and CNV. So that is how, in terms of the molecular point group, it is easy to classify whether the molecule would have a dipole moment or not. Thanks for watching, dear. See you in the next session. Thanks again for watching.